Okay, well, welcome everyone, and thanks very much for coming to the first of our water sessions for the Cape Town Together Food Growers Collective. So you might have seen the agenda. I'm giving this talk for the first time today, and I don't know how long it'll take. So we'll just have to see how it goes. And I sort of wanted to try and find a balance between sharing enough that you feel you're sort of going away with something useful and not overloading you. So yeah, I'll really welcome feedback on that at the end. Yeah, please just turn off your screens and your audio if you're not speaking. And so if you do want to speak, there will be points for questions along the way. Then just turn on your sound at least, or your audio as well. It's nice to see who's talking. But otherwise, just to save bandwidth, just to rather turn off your audio and video. Thank you. Okay, so first of all, it will be a few sort of graphs and things, but just to give you context, it might look a bit serious, but let's just get through the first part just to give you sort of the context, and then we'll get into other stuff. Oh, right, that didn't work. First problem. Okay, here we go. So in Cape Town, we have a Mediterranean climate. And that's the dark blue part here in the picture. It's where we have rain in winter and a warm, dry summer, which is a problem, of course, for growing veggies, because just when it's really hot and the soil is drying out, we don't have water. And the whole rest of the country does. They've got summer rainfall. So it's just the Western Cape that has the winter rainfall, and that's what we call a Mediterranean climate, because that's also what the climate that they have in the Mediterranean. And this is a rainfall graph for Newlands. Each line here shows 1 year. So as it moves from January to the next January, you see the line goes up each time it rains, and it ends up over here with a figure, with an amount basically of how much rain you've got that year. And over here, I was able to highlight the years I wanted, and I picked all the most recent years, the 5 most recent years. And you can see that those colorful lines are lower than a lot of the previous years. So the last 5 years, we've had a lot less rain in Cape Town than in previous years, which is very likely connected to climate change. And in future, we might have even less rain. You can see that this red line here is 2020, and it's looking like it'll also come in, you know, better than some previous years, but still not that great. And that's Newlands. Newlands now gets about 1,300 mils a year, but you can see that in the past, they got up to sort of 2,300 mils in a year. I will tell you about what a millimeter of rain is, but this is just to get a sense of quantities. Blackheath is another spot that I was able to find on this climate systems analysis group. They've got a lot of historic data on rainfall. Blackheath is near Kailsrivier, and they also have had the lowest amounts of rain in the 5 most recent years. You can see they used to get a lot more, up to what, 750 or so, and now it's coming in under 400, under 400 mils in a year. And we'll just do one more of these graphs because I know Vuyani's in Gugulethu, which is near the airport. Unfortunately, there isn't a recent graph for that place, but you can see here 2017, was coming in very low. And I'd say, yeah, on average, you're probably getting about 350 mils a year at the airport, and probably the same in Guguletu. So when we want to think about, what can we do about this, we need to apply a whole combination of strategies. It's not just one thing we need to do. So we need to do what we can to catch as much water as we can and to store it. And then also do whatever we can to lose as little water as possible. So, it's on the sort of the supply and the demand that we want to try and be as efficient as possible. So just going back, of those three things, I'm going to be talking mostly about the catching and storing. So just quickly to look at the losing as little water as possible. That's what the next screen is. You want to make sure that you've got lots of organic matter in the soil. So really good, healthy, loamy soil, plenty of compost, because it acts as a sponge. That kind of soil stores more water than any other kind of soil, a lot more. So that's one place you can actually store your water, is in the soil. You want to have a thick mulch, like really thick, sort of 10 centimeters or so. Plant densely together, so you've got a nice canopy over the soil. So plant your plants close together. Look at things like windbreaks, tunnels, shade cloth to protect the soil from the wind and the harsh sun. Don't leave the soil exposed to the sun. And again, so that's mulch, cover cropping, and so on. So whenever I see an exposed soil, I sort of think of a wound. It's like nature's skin has been cut open, and nature will cover it over with weeds if it can, if there is enough water. Yeah, we should try and keep the soil covered as much as possible. Then, of course, it also is good to look at what crops you've got. So if they're indigenous or water-wise, they'll need less water. And there are plenty of vegetables that use, well, I'd say they need less water than others. There are others that need a lot more. Then we can also look at things like wicking beds and sunken beds. So sunken is sort of the opposite of raised beds. They're actually sunk into the ground so that the water doesn't dry out as easily. And then lastly, to sort of try and make sure that no water leaves the site. Sink it into the ground before it runs off. Now, each of those things one could talk about for a few hours, I'd imagine. But just to touch on those things about not losing water. So then the next thing I wanted to look at is just, well, how much water do we actually need to get a sense of, yeah, how much do we need to get through summer? And that really varies hugely depending on where you are and on those things we just looked at. So if you get all of these things right, then you're going to need a lot less water than if you're sort of in a really exposed, sunny, windy place with sandy soil and no organic matter, for example. So this is for roughly mid-October to mid-May, which is approximately when we probably would have to water because we wouldn't have rain. My estimate is that we'd need about 2,000 liters for every square meter of garden. And of course, again, as I say, that really varies, but it's just a sort of a ballpark figure to start getting a sense of what we're looking at. And I will be talking about earthworks and getting water into the soil, but it's almost unavoidable that we also actually need to store some in tanks. I mean, it is unavoidable in my experience. And so, yeah, that number can, as I say, really vary. It might be more, it'd be 3,000 or 4,000. I don't know how high it could go with really bad conditions. But the aim, of course, is to try and get that number down as much as possible without stressing your plants. But, you know, to really protect the soil and the whole garden as much as possible. Right, so now, what are the sources of water we have for gardens in the suburbs or in a city? We'd like to distinguish between roof water and storm water. Both of these, of course, are basically rain. But roof water is cleaner, and so it can be used for drinking water in the house and for cooking if you filter it. But stormwater has come off a road or a paved area, so you wouldn't use that in the house, but it's perfectly fine for the garden. Then grey water is water that you've used already in the house. So it's being reused. And then we have well water and borehole water, if we're lucky to have that in the area. But it is quite problematic using water out of a shared aquifer. That's also it's a limited amount of water that's down there, and if we use it, then it's gone. The borehole water, at least. Well water is more available. It gets replenished every year, or certainly every few years, because this is a more shallow thing. A borehole it goes deeper down into other parts of the ground. Right, and then lastly, we also have municipal water, of course. Okay, just before I continue, is everyone with me? And is the pace working for you? Am I going too fast? Do you have any questions? I see some thumbs up, thank you. Okay, I'll continue. So roof water harvesting, this is a really nice example. You can see that there are gutters along the roof, and then these pipes collect the water from the gutters and lead it into these tanks. The tanks are connected at the bottom, which means that when one tank fills up, the others also fill up. So the water will go up and down in all the tanks at the same time. And then there's also an overflow pipe here, which actually comes into, it looks like a little channel they made here. So that water, when it overflows, will be taken somewhere else, so it won't go to waste. So how much rain can we catch off a roof? I wanted to sort of try and explain to you how we can calculate that. So the catchment area is the space that you're going to catch the rain off. And if you've got a building with a pitched roof like this, you actually just have to imagine a big square on top of it and measure how big that would be. So you're going to measure the length of the roof along here, and then you're going to measure across here between the two roofs. And then that gives you the length and the width. And when you times it, the length times the width, that gives you the area of roof in square meters. So if you've measured the length in meters and the width in meters, then you'll get square meters from your calculation. So for example, if you've got a building that is 8 meters by 11 meters, you're going to have 88 square meters of catchment area. And the way that is written is you put a little 2 beside the M. That means that it's square meters. Or another example is if you've got a building that's square, you've got 10 meters by 10 meters, you then end up with 100 square meters. So that calculation works with any area. You can also figure out the area of a parking space, for example. If, say, there's a big area of, hard surface that people... Pardon? Okay, I just heard some sound there, but I didn't hear what you were saying. Yeah, if you were calculating the area of a parking space, it would be the same. So it's not just if you're calculating off a roof, any hard space that you want to see how much water falls on there. If you can then somehow try and gather the water off that space, this is how you do it. So you multiply the length by the width, and that gives you your square meters. Then we find out how many millimeters of rain we've got. And you might wonder, well, what does that mean, a millimeter of rain? Well, the top of my stairs happens to be just about a square meter. So that's this area here. And when you have 1 millimeter of rain on a square meter of space, you've basically got a liter of water. So if you imagine a tray was made exactly the same shape as this square meter, and you were to pour the milk into that tray, the water would stand exactly 1 millimeter high. That's what that means when people say we've had a millimeter of rain. It means that every square meter, every area that is this size has received 1 millimeter of rain, or sorry, 1 liter of rain. That's quite an important concept. So maybe we should just stop right there and just make sure that everyone's happy with that. Would you like to ask any questions? I'll give you some time to unmute, or maybe write in the chat. Erica's watching the chat, so please tell me, Erica, if anyone's got any questions.
Not so far.
Okay, all right, good. Then we'll continue. So that's your liter per square meter is 1 mil of rain. So now, if we're still looking at how much rain we can catch off our roof, we need to find out, well, how much rainfall are we dealing with? You know, are we talking, maybe we're talking about the rain that we're expecting the next day, and we see there's going to be 10 mils of rain, right? Or maybe we're looking at historic data, so that would be old information about what's happened in the past. And this website here is great for that. That's where I got those graphs from at the beginning that tell you, you know, how much water we've had in a particular area in the past, because obviously we can sort of expect or hope that we'll have a similar amount this year as well. And weather apps as well will give you an indication of how many millimeters you might be expecting in a future rainfall. So now, once you've got your area, your catchment area in square meters, and you've got your rainfall in millimeters, so that's mm is millimeters. If you multiply those, then you get a number that is the amount of liters that you're going to catch. So this little drawing also shows that. So you're multiplying the area of your roof with the number of millimeters that it's showing in the rain gauge, for example, and that gives you the volume of water. They say here cubic meters, but that's actually not quite right. It's actually in liters that you'll get the number. So that's up here, it says liters. Here's an example. If you have a roof space that's 120 square meters and you get a rain event that's 15 millimeters, that means you're going to be able to catch, if you manage to catch it all, about 1,800 liters. Or similarly, if we're looking at sort of annual rainfall, for example, if say you've got 100 square meters of space that you're catching from, and we know that Blackheath gets about 350 millimeters of rain every year, that means that you might catch in the order of about 30,000 liters of water in that area. Actually, you always catch a bit less, but we needn't go into that because it's yeah, you don't catch every liter.
Jill, there's a question from Google too.
Yeah.
Then you started to be.
I can't hear you.
Can you hear? Can you hear now?
Yes, okay, barely, but I can.
Man, we just don't want to lose you. If we understand that if we want to measure how much rain my rooftop can catch, we've picked up that I must first calculate the length and width of that roof.
Exactly, yep.
It's just a flat.
Yes.
Yeah. And then we find out the millimeter of rain per area. So in other words, now I must find out how many millimeters of rain does Kokuletu have. Am I right?
Exactly, yes.
Now, understanding that and converting it to our square meter in a roof, you mentioned something like a liter of water per square meter.
Yes. Okay. So yeah, so if we go back here, for every millimeter of rain that you catch, you're going to get 1 liter on each square meter. So if you've got 100 square meters, you've got 100 squares of this size. So for every millimeter, you're going to get a liter. So then you're going to get 100 liters from that roof for every millimeter of rain that you get. I don't know if that makes sense.
Yes. Yeah.
So that's why you can multiply it.
Okay.
So you can imagine your roof is covered in a whole lot of squares this size, and you get a liter of water on each square for every millimeter that you get.
Yeah. No, we've got it. Yeah. Thanks.
Great. Okay.
There's another question. There's another
Sure.
question, Jay.
Sure.
Sorry, man, you've calculated the, I think I don't know whether it's a rectangle that you've calculated or it's a, but you say length times breadth. But that one is a roof truss, that one. What about the triangle, the triangular thing?
Okay, yes, thank you for, yes, I didn't make that clear. We go back to this one. The same amount of rain will fall. It doesn't matter what shape your roof is. The same amount of rain will come down from above it, right? So, and you have to work out the size of a flat piece of roof that would have the same size, the same length and width as this pitched piece of roof. So yeah, you can just imagine that your roof is actually flat. So don't worry about the fact that it's actually going up and down again, which actually makes it bigger than if it was just flat. So yeah, you just need to measure the length and then the width straight across. You don't go up and down again. You just measure straight across, because that will give you the area then. Are you happy? Good. Okay. All right. So this is a picture of my place. And I'm just using it as an example because I know my place is maybe quite different than yours, but the principles are the same. You know, we can learn from each other. And what we've done here, I think you can see a few examples of what you can also do. So I just want to explain first of all what is in this picture. The yellow line is it's the municipal supply, and we actually use very little municipal water. So in the house we can choose to use municipal, or we also have this light blue arrow. So we catch water off the roof and put it into these tanks here, and then we pump it back into the house. So this light blue water is cleanish. It's clean enough to use in the house. We catch it off the roof, we put it in the tanks, and we pump it back into the house. So that's a sort of a separate system. But we do take the overflow from those brown tanks. When they're full, we take them down into some other tanks. And they are tanks that we use for the garden. It's these ones, and also these tanks at the top. So they're all for the garden. So into those tanks, we put water off the road. You can see up here, this is a dirt road up here. So we just, you'll see a little video just now. We go and sort of dig little channels into the road to just make it come down into a pipe. The pipe brings it down past the house and actually under this blue arrow straight here into what is a swale, right? I'll also explain what a swale is just now. But I wanted to give you the overview first. So all the water coming off the road, and it's a huge catchment area, right? So we haven't measured that, but we think it might be something like 1,000 square meters. So every time it rains, we get a lot of water coming into the garden this way. So the water comes down past the house and into the swale. We also catch water from next door, off their roof and off their paved area. And all that water also comes down and into the swale. And then when this red swale, this first one is full, the water overflows into the next swale. And when this one is full, it overflows into the next one. And finally, it flows into this one. And maybe once a year, we manage to fill all the swales. And that is a huge amount of water. So it could be something like 100,000 liters when all the swales are full. Right, and then the other thing we use is gray water. So when we've used water in the house, it comes out through a pipe and also goes into the swale. So yeah, that's what we do. And we've got a food forest in this area, and I'm going to show you how that came to be. So before we did the sort of permaculture thing with Alex and Tahir actually in 2016, I think a number of you will know them. I had this garden, I had to cover it with netting, and I was really battling, and I just never had enough water. And I was using municipal water, and it also cost a fortune. I was taking the gray water into a little pond in the middle, but we actually don't use enough water in the house to provide the garden. This is another part of the garden. Yeah, you can see it was quite dry, and we were growing stuff, but it wasn't ideal. So then I got hold of Tahir actually, first of all, and he advised me that I needed to put in swales. And he was the one who suggested taking the water off the road and from next door. And actually, I waited for quite a while. I was scared. I actually thought we're going to get flooded and we won't be able to manage. So then I did a permaculture design course with Alex and Tahir. And after I'd done the course, then I understood it, and I wasn't afraid anymore that we would flood ourselves and the neighbors and everybody. So I decided to go ahead. Yeah, we completely started from scratch. You can just see some posts here where we started marking out where we were going to put the swales. This is Magnus. Some of you might know him. He's also been at Seed and knows Alex. He did a course with her. So this is when we were starting to dig the swales. So just to explain, a swale is a ditch, right? And a berm. So the berm is the bit that sticks up out of the ground, and the ditch is the bit that it gets dug down into it. So as you dig out the ground here, you put it into this berm here. And that's all a swale is actually. And what the swale does is, right, the water comes into this, the ditch part of the berm, and then it flows through, sorry, the ditch part of the swale, and it flows through the berm and down into the soil. So it starts making this sort of groundwater lens as it flows down the hill. Here's another swale, and it's completely on contour. Right, so I'll just explain what that means. On contour means that the level of the bottom of the swale here is all one level. It's exactly the same level. So if you put water into here, it won't flow to one side or the other because it'll just sit like in a bath. You know, when you fill a bath, it just comes, the water travels up all in one level because it's not going anywhere. And that's what happens here. So when you build a swale on contour, because everything's exactly the same level, it's not flowing downhill anywhere. So here's another illustration of what contour means, because you could actually sort of draw lines around on the earth that are exactly the same height above sea level or above some other level. So you can actually imagine these sort of slices going through the land. So if you run along one of these lines, you stay at exactly the same height. If you were hiking on this mountain, you wouldn't be walking up or down at all. You would be staying exactly the same height. So it would be as if you were walking on a flat road. So that's what contour means. A contour line is a line of ground that is exactly the same height along the whole line. And when we look at a map, you might have seen maps with these lines on. Each line is a contour line that has exactly the same height. So when you want to build a swale, you make sure that the swale is on one of these lines, that each part of the swale is at exactly the same height. And that's what we did here. It might not look like it because it's funny when you look with your eyes, it seems that things aren't level, but actually this is completely level. We went to a lot of trouble to make sure it was completely level. So that's that first swale that we saw in the picture starting to take shape. Just is everyone happy with my explanation of contour? Okay, I see some nods, thank you. And actually it was a permaculture group of students that came and implemented the garden that day, which was absolutely fantastic. It was a great day. So this was April 2016, and we had put in this whole section here. There's actually two swales, this one here and another one, and a whole bunch of trees. I forget how many it was. About 15 trees, I think we put in that time. Bernice, all cool? Okay.
Hi, Jill.
Oh, hello.
I just want to know, how do you achieve the same level of your contour?
Right, yeah, that's quite tricky. There are different ways. I haven't gone into that in this presentation. If you can get hold of a dumpy level, we borrowed one from Tahir. That's the easiest way to do it. But you can also use an A-frame, which maybe Bernice can explain to you, because Bernice has done this before as well. So that's a very basic way of finding the next point as you go along the line. And you can also do it with a hose pipe and water, but it's really tricky. We tried it. But yeah, if you don't have either of the other two tools, then you could try it with a hose pipe with water inside. I think the A-frame really is the easiest way to do it. Yeah.
Thank you.
Okay. So October 16, we then put in another section, and another bunch of students came to help put this part in, and the other two swales were put in there as well. And that's what it looked like then. And I'll just run through these pictures quickly now to show you how it changed over time. Oh, I also wanted to show you these tree pans. So these are also earthworks to show how we designed it so the water will actually flow into a shape around each tree. So it'll hold the water. So each tree that we planted got a little basin around it, a tree pan as we called it. So also just means that the tree gets a bit more water than it would have otherwise. And I also just wanted to show how beautiful these shapes are, because we had these sort of very up and down straight lines before. But when we followed the shape of the land, we ended up with these lovely rounded shapes, which I just think look so much nicer. And it's just a more pleasant space to be in, actually. I think it's very beautiful. So this is now a year later, September 2017. It's starting to come together. It's all growing and quite nice and green. But then the drought hit and we just didn't have enough water and it got quite parched. But we squeaked through with the amount of water we had. We didn't lose too many plants. And we put in more tanks, the tanks at the top of the picture that I showed you initially. And that allowed us then to store more water and get through the following winter, or the following summer, I should say, much better. So by October 19, it was looking like this. And then July 2020, you can see it's turning into a jungle. So it's really getting beautifully covered over. Nature's doing its thing. It's just spreading out. The soil is getting better and better. You might know this plant here. It's a Tagasasti. It's a nitrogen fixer. We've got a lot of them in the garden. You can see all these bits that are popping up are actually all these Tagasastis, which are fantastic nitrogen fixers. And fodder trees as well. So if you have animals, they can eat the leaves. And I just took this picture yesterday to show you what it's like right now. And if someone's in the garden, you actually can't see them anymore. You have to sort of shout and say, hey, are you there? Because you can't see them. And so I'm loving it. So we have about 35 fruit trees and we're starting to get a bit of fruit, lots of medicinal plants, some berries, blackberries, olives, and banana here where the grey water comes out. So it's taken time and we're still not getting a lot of food, but I think it's now getting to the point where in the next few years, we're really going to have a lot of fruit, nuts, avos coming off these trees. So I think it's been quite a worthwhile investment of time. And of course, we also spent money on the tanks and put in a lot of effort to get this far. So yeah, I wanted to give you that as an example of how nature really kind of comes to the party once you, give it what it needs, the water and all the rest. Then I wanted to show you, oh, just got to figure out how to do this, sorry. How do I get there? I wanted to show you a little video. I had it all
While
worked
you're
out.
figuring that out, is there any questions?
Yeah. Okay, if no questions, then I'm going to play this little video. This is us catching water off the road. So you'll see now. So this is the storm drain at the end of our dirt road. And normally all the storm water goes down there. And this is my partner, Hilton. And he's sort of helping the water into our drain. And you can imagine that actually quite a lot of water comes in this way off the road. And it all goes into a drain and into a big pipe that then takes it down into the swales, like I showed you in the picture at the beginning. Excuse the annoying music. And there we are, it's coming out of a pipe into the swale and filling it up. And that water is going to soak into the soil and really hydrate it. There we are. That was that video. Get back again. Okay. And I just wanted to also show you that you can obviously also use things like bricks and concrete or whatever to formalize things. I mean, if you feel that you can do that in your area. So we put a grid across our neighbor's driveway because they were getting a lot of water down their driveway and didn't want it. And we really wanted their water. So we came to this arrangement and put a hole in our wall. And so now we don't have to dig the way you saw in the video. It's a bit more organized because actually I think the neighbor really wanted it to be more tidy. So that's how that looks now. We've just recently finished this thing. Right, so the principles of regenerative water systems design. Firstly, of course, conserve water. Save it, don't waste it. Start at the highest point, because at the highest point, you've got the most control. You can take it to the most places. And it also might not be going very fast yet. As it goes down over a slope, for example, it can really pick up speed. So you want to get it as early as possible at the highest point. And then you want to slow it, spread it, and sink it. And that's exactly what a swale does. It slows the water down because it's on contour, so it's not flowing anywhere. It spreads it out across the whole length of the swale, and then it sinks it into the ground. And if we've got enough sort of organic matter in the soil will hold that water. If it's just sand, it'll fall out the bottom and vanish into the aquifer, which is not a bad thing, but it won't be in your garden anymore. Right, the next principle then is store it. So that's obviously not just about storing in the soil, but in tanks and things like that. And then reuse it. So, you know, put your water to work. You know, use it in as many ways as possible. All right, so this is a harvesting landscape, an example of one where the water used to just flow away off the roof, off the road, off the garden. It just all flowed away and went to waste down into a storm drain. And then in this picture here, they're storing it in a tank, and they've also reorganized, or they've done some earthworks with a path or a road that drains water into these sunken basins. So the water gets stored in the ground instead of flowing away. And we want to create a sponge. I love this picture. I think it's it really just, it looks amazing how you can really just imagine how much water is in that soil. It's uncovered, so they need to plant it soon. But yeah, it's beautiful. And yeah, when you're designing, always design for disaster, design for more rain than you might expect. Have an exit point in the design that avoids flooding. Make sure you're not going to just flood your neighbors or cause a problem. So you need to think through how you're going to handle it if you get more rain than you're actually expecting. So take it back out to a storm drain or yeah, whatever that would look like. But do keep it in mind that even though with climate change and the drought and everything, we might be expecting to get less and less rain. But actually, I think what climate change really means is more disruption, more extreme events, which can also mean suddenly a lot more rain than you're expecting. So do keep that in mind. Here's another example of catchment off a path, off a road, and into these spaces between the hard surfaces. This is another, pardon?
There's a question from Stephanie.
Yep. Hello, Stephanie. I think you need to unmute or write in the chat.
Can you hear me?
Yes, I can.
Okay, so we are in an occupation space and we have some grey water system that we would like to remedy. We have grey water running over our site and it's causing runoff and topsoil loss.
Yeah.
The problem is we don't know what is in the water because it's coming from a bathroom, and because we are in an occupation, we're not sure what products are in the water. So we just trying to figure out what are the best ways to remedy that. Can we just directly plant into that, or do we need to have some kind of system before we use it in our garden?
Okay, I am going to cover grey water in a little bit.
Okay, cool.
So if you can maybe hold the question until then, and if I don't cover it, please do remind me. But I think I do have, I might cover it. Let's see.
Okay,
thanks, Stephanie. So I just wanted to show here, how the rain gets collected on the hard surfaces and pours into the basins in between. And then, yeah, you've got this lovely growth in between. These pictures are from Brad Lancaster, the guy we were hoping to have on a Zoom, actually, but it seems not to have worked out. Here's some more examples of, this is called curb cutting, where you actually shape the curb or cut it to allow water off the parking area into a green space in between. And this is another example where the water gets collected on the path or road and then brings water into this, it looks like a swale, or at least the ditch part of the swale that's growing there. And that's another example there as well. All of these are just examples of how you can bring water off the road, off the parking, off the pavement, and into green spaces that are a bit lower down. That's a before picture and an after picture. So we can start really looking at the spaces around us and see how could we apply these ideas ourselves. Here, okay, we're already on the grey water, Stephanie. So this is an example of a washing machine where the outflow pipe is it's like a flexi hose that you can just actually pull out of the one pipe and push into another one. So he's marked these pipes. One's for the fig, one's for the peach, one's for the orange. So each time he washes, he puts the pipe into this flexi pipe into a different one of these pipes, and the water then flows out to a different tree in his garden. Washing machines are amazing because they actually use a hell of a lot of water, and they've got a pump, so it can actually push water uphill a little bit. So it's maybe one of the easiest ways to use your grey water, because it's a sort of the lowest hanging fruit in a way if you've got a washing machine, because they do actually use a lot of water. And yeah, I think I've got a note here. Sorry, I'll come back to that. But yeah, I'll talk about the soaps just now, but I just want to go in the sequence, otherwise we'll all get confused. Here's another grey water solution where the water comes off the roof into a barrel, and then there's a little tap in the barrel, and the water gets used for washing hands or whatever they do here. And what I particularly love about this is that they use gravity for getting the water into the tank and for getting the water out of the tank. And usually you kind of have to choose if you're going to use gravity on the way in or the way out. But because the barrel is quite small, it can be up high, and you can actually use gravity to get the water out of the tank as well as into it. So grey water is water that's already been used inside the house, as I said earlier. You obviously wouldn't take it from the toilet or even from the dishwashing sink, because it's going to have a lot of greasy water in it. But you do take it from the sink, the shower, the washing machine, right? So those are sources where you would have some soap or detergents in, but there's nothing too serious, and there's a lot of water as well that comes out of these places. And I think we can say it's completely free, because it's been paid for before for whatever use you put it to before. Now the issue with grey water, and I think maybe this comes to Stephanie's question, if you use ordinary detergents and shampoos and things, it tends to be alkaline, which is like the opposite of acidic. I'm busy here, sorry. And it tends to be salty as well, because there are salts in these washing powders, and there are also phosphates. Phosphates are actually used as a fertilizer. So you might hear, well, it's fine if it's got fertilizers in, because, or if it's got phosphates in, because it will help to fertilize your garden. But actually, the soil can't store it all. And especially if you've got sandy soil, most of it will just run off. So instead of putting this water into the sewerage system, which would then deal with these phosphates, you're redirecting it into your garden, but then it's getting washed out of your garden and into the waterways. So the rain will wash out the salt and the phosphates, but the salt can eventually build up and kill the plants. And the phosphates in the runoff can kill life in the rivers and waterways. So if you want to use grey water, it really is advisable to use a biodegradable and phosphate-free soap or detergent. So washing soda is an option, a fairly inexpensive one, if you want to use your grey water in the garden, because otherwise you are running the danger that you might kill the garden and life in the waterways. So just to answer a bit more of Stephanie's question, though, yeah, I get that you can't just tell people what to use. They're just going to buy whatever they can or use whatever they can. And you know, if you start getting fancy with biodegradable soaps and stuff, it's just not going to work. So then I would advise that you try and put in some sort of a reed bed. So run the water through a system that has like gravel and sand and water plants and things in it that will then draw out a lot of these chemicals before you let it into the veggie garden. I don't know if that helps you. One could do a whole session on reed beds actually and water filtration. But that would be something to look at, I think, in your example. Stephanie, are you would you like to, sorry, have you got your answer or?
Yes, the answer's been the question has been answered, but one extra thing that I would like to ask, what are our best plants to use in grey water systems?
Okay, I'm going to have to look
first
that
step.
up. Yeah, I'll
Okay.
I'll find that out for you, but I
Okay.
couldn't tell you off the top of my head. I did
Okay.
used to have a grey water reed bed, and it had things like sort of bulrushes and papyrus and things like that in. But I think we could find a plant list for you, because I can't off the top of my head now tell you that.
Okay, thank you.
Okay. Okay, the other thing about grey water is you really shouldn't store it at all, but certainly not for more than 24 hours because it's going to get really stinky and horrible. And when you do put it into your garden, direct it directly onto the soil, not onto the leaves of the plants, because the soaps and things can burn the leaves. Yeah, and then we have municipal water, which, you know, depending on your context, might still be an option. So the first 10,500 liters may be free in your area. And then the next 25,000 liters, you pay 36 Rand per 1,000 liters. So it starts getting expensive quite quickly. But it would be worth looking at your price per liter, comparing it with other solutions like tanks cost money. You know, everything has a price. And you might find that depending on the quantities and how much of your municipal water allocation you actually use, that it is still an option that you should also consider. One thing is, though, that municipal water does contain chlorine and we're not quite sure what else. So, you know, rainwater is better for your plants than municipal water, but we take what we get. Oh, and lastly, I just wanted to say boreholes really only as a backup, because they go right down into the hard rock, which only gets refilled over hundreds of years. So, you know, if you're using that resource, it's not available to future generations. Whereas a well is much shallower and it goes into the groundwater that's right there, the water table. So that will refill. But the borehole goes down here below this impermeable rock and is likely to be taking out. It's a non-renewable resource, basically. Right, then we come to storage. So obviously we want to store it in the soil as much as possible, but we can't get around also having some other form of storage for irrigating in summer. So there are tanks, and again, I'm really just doing an introduction here because each of these topics one could talk about for a long time. But the tanks come in plastic. One can make them, or you can try make them yourselves out of ferrous cement. And there are also steel ones. In the old days, they used to use steel. These days, it's plastic really is the most common form. And we've all seen them around Cape Town, especially since the drought started. Then, of course, dams and ponds are another option, but you do lose a lot of water to evaporation. So if you can't cover the water, you lose a lot in summer. And I know that Bernice mentioned they've got an old swimming pool at Sissy Goal House. So that might be quite a fantastic place to store water. And I know it's going to need some work, Bernice, but yeah, again, it's sort of using what you got. Right, we're almost at the end now. And I just wanted to suggest some things to look at when you start mapping your site. So permaculture has a bunch of principles, and the number one principle is observe and interact. And it's really worthwhile getting out into your area and into the space around your site but also into your site itself, and just look at what happens when water falls. You know, where does it, what happens basically? So observe and interact, and it's worth taking time to do that. Another one of the principles is small, slow solutions. So don't rush in and try and fix everything at once, but yeah, observe and interact, and then start in one patch at the highest point, and then work your way through the site. So the questions I'd like to ask, or I'd like you to consider when you're thinking about your site: obviously, what water sources are there near your garden? Where is the highest point in your site? Can you catch water off the roof? Are there any gutters and downpipes, right? Is there a washing machine? And as I said, it's a source of a lot of grey water, and it can even pump slightly uphill. Obviously, the key thing is to make sure you're not using soaps that would kill off your garden. Then to think about how could you maybe catch stormwater off the roads, off parking areas, off other hard surfaces. How does the land slope? Where does the water flow when it rains? How does it run? Where does it pool? Where does it move fast? Where does it move slowly? Where are the stormwater drains, right? That's your exit point, so for your disaster planning. And then, is there a well point or borehole on the site, or maybe even nearby? Because yeah, maybe you can somehow make an arrangement with a neighbor who does have a borehole or a borehole or a well point. So that's it from me. I'm open to questions now.
While everyone's waiting, maybe I could just add a couple of points to that last list that you had, Joel,
Sure.
which is great for everyone to think about. Just because you have a roof doesn't mean that you can not also capture water from a neighbor's roof and bring it into your space. So a whole neighborhood can get together and look at how the water flows through an entire neighborhood and make a neighborhood water plan, which will make you way more resilient. And then you've actually got to be the crazy person out in the rain, watching where everything flows, and run around with a little spade and actually make channels and redirect water, and notice how quickly and easy it is to permanently redirect that water into a space, into, start off with like redirecting it into fruit tree and tree pans. But be the person out there with the spade, because it's amazing what you can see, and then you can start designing.
Exactly. Yeah, I agree.
So maybe one of the things that I've noticed at the beginning of lockdown, I had a lot of time to look at and observe. And I covered all my pathways with mulch and wood chips and whatever. And I could see what the significant advantage it was, in that it really allowed the water to sink rather than just flow over the land. And so in time, I'd like to look at mini earthworks, like the mad person with the spade in the rain, Erika. So to see how one can do that in a much smaller, on a much smaller canvas. Then, I mean, you've got a much bigger space, or at Sissy Gould, they've got a much bigger space. So can one make like mini if you have like a small space, would a berm be more appropriate? I'm just thinking of ways in which you can let water sink into your soil.
Yeah, definitely. I mean, yeah, there are many ways. whether you're making basins, berms, or those ditches, it sort of depends on how you want to design your garden. And it's all relative, you know, it's just different levels, it's different heights. So whether you call it a ditch or a berm, or if it's actually, you know, I don't know if I'm making sense here, but if it's all fairly much on the level because it's a small site, then, you know, the height differences aren't going to be so big. But yeah, definitely, you're wanting to sort of spread it out, slow it down, and sink it in as much as possible.
Thanks.
Yeah, thanks, Pennies.
What's his name?
Maybe one more thing from my side, if I may. A lot of people are going to be sitting here going, okay, well, we're actually at the end of winter now. We've got summer coming up. We don't have tanks. We don't have things built yet. Yes, we can plan and design and build it, but what about getting through this summer?
Yeah.
And I was thinking, especially in areas where you have already large communities that know one another, and you can get the teenagers and the children to do daily runs with like a trolley and a bucket and pick up used water from everybody's house and go and take it to the community garden and water. And that can happen through the summer if everybody works together. You can make sure that you specify which type of waters you want and keep it separate. These are things that are wastewater that maybe aren't exactly pure, can go into your fruit trees and tree pans, and then the water that's lightly used can be going into your lettuces and tomatoes and so on.
Yeah, that's a good idea.
That's what could also be done in the occupation. Specifically, certain type of water, then it's taken straight.
Jill, I'm just wondering, and to the whole group, actually, it would be really lovely to see this in action. So I know there's some examples, and I'm hoping that we'll be able to go see it. And then, of course, have the opportunity to maybe get you in for a walkabout with us on our site to help visualize and imagine, you know, what possibilities exist. As I mentioned, specifically with the swimming pool that's now become quite an eyesore. We really want to move on that sooner rather than later. So if there's anybody even on this call who would be interested to swing by Sissi House and come help cast fresh eyes on an old problem towards a solution, that would be really great.
Yeah, definitely. I think it would be fantastic if everyone could go and visit different sites, and we have talked about how we would go about that. And yeah, I think Erica will probably organize all of that. But I'm definitely up for coming to visit sites. I mean, your sites that you still want to design, but also going to other sites where there are already examples of this in place. So I'm happy to travel. I've just said it before. I just need to keep my distance and wear a mask and all that. I'm being super careful still because I live with high-risk people. But I can definitely come to outdoor sites, and I'd really like to. It'd be interesting to do that.
Nice.
Are there any other questions?
I just have a comment. I just want to say thank you for the session. It was very informative. I don't have such a land. I'm just a home gardener or an urban gardener, but it's very informative. I'm starting to plan in terms of collecting water, you know, either via tank or installing a well point or something like that. So yeah, I'm busy looking at maybe for next year. Like Erica also said, some of us haven't been planning, you know, this whole winter. So we are gonna, it is gonna be a problem in summer. And I just ended up paying quite a bit of money now in arrears water to the municipality. So I'm trying to not do that, you know, and grow my vegetables. So very, very interesting. And I am also reading up on it. I know somewhere in Malawi, I was doing some research a little while ago. It's almost like they put these little cups, like little holes that looks like cup holders, into the ground, and that sort of increases the surface area for rain, so that the rain sits in this little cup of soil. Well, it's a little dent that's made into the soil, and then it sits there for longer so that it doesn't run off, and it stays in the ground, which I found was also very interesting. I don't know what the method is called. Maybe it's a cupping method or something. Yeah, but thank you very much, Jill, and everyone else for the session. It's very informative. Thank you.
Yeah, thank you for that comment. I can't see who you are, but lovely comment. Thank you. And I think that idea of the cup sounds very interesting. I see a face now. Hello, Shahid. Okay, nice to meet you. Yeah.
Can you guys see me now? Hello, everyone.
Hello, Jill.
Hello, Boyani.
Hello, everyone.
There's another question around.
Yep.
I'd like to raise, I want to know how much control do you have from that water you're collecting along the road and then it goes to the drain? And then do you have a catchment point in your yard if you're going to divert that water to come to that drain?
I'm sorry, I'm going to interrupt you there because I'm really battling to hear you. Maybe you can come closer to the microphone because I can't hear the question. Sorry.
My question is, how much control do you have from that water that you're diverting from the road and then they go to the drain? So in that drain, do you have a catchment point there whereby you can go and fetch the water and then you use to your garden?
How much control do I have once the waters come off the roof? Sorry, I'm not sure what the next part is.
No, it's storm water that is on the road, the runoff water. So she's saying she understood that you can divert it into your space. And how do you control that? How do you collect that into your space?
Oh, okay. It depends on your site. If you can bring it straight into your garden through whatever gate you have, that's ideal. In our case, the garden's at the back and the gate is at the front. So we actually put it into a drain and into a 110 mil pipe that takes the water down into the swale. But it really depends on your site as to how you would move the water around. Maybe you can just make a little channel, a little drain that would bring the water into your site. And then did the question also maybe touch on what to do if it's too much water? I suppose that is also an issue. And yeah, again, depending on your site, you would have to think about, you know, what level of water can you take? If suddenly there's this huge rainfall, what's going to happen? Where will the water go once maybe the drain is full? So it really depends on how things look where you are, but you would need to think about a way to let it flow back out onto the road maybe. depending on how it looks. Okay, any other questions?
In Gugulethu, we've got the idea that we really would like to see our streets with fruit trees and diverting water into those tree pens and all that. Yeah, this scary part is, won't we be fighting against municipality? What will happen then? You know, so is it something that you, it's like an ambushing the road, waiting that it's dark to cut through and create those berms?
Yeah. I'm not quite sure what I should say sort of officially and who's going to watch this. But I know others have done it. There's someone down in Fisher who I know has definitely done, he's cut the curb and that seems to be accepted there. And obviously what we've done on our driveway, we didn't ask the council, but we felt that we should be able to design our driveway in a way that the neighbor doesn't get flooded and we actually take the water because we actually want it. But yeah, I don't know what would happen if the council weren't happy about that. And so I think it's important, it would be worth, starting that conversation with the council to find out what, are they actually, how do they view that? Are you going to get a fine or what would happen? Because I mean, obviously you can't just tamper with the property of the municipality. But if it's seen to be actually, growing food, greening the city, making the place a lot better, I think they'd have to be really cold-hearted to punish you for that. But yeah, I don't know what the official line is.
Sorry, I've got well, I don't know, comment. A friend of mine was involved in Langa's, Langa had some greening a little while ago. They had some sort of greening the city or their little city space project. And this friend of mine was involved in that. And I think she was busy helping recruiting some of the youth in the community. It was obviously a community-based project. So maybe I don't know, I'll ask her how she went about navigating the municipal, I don't know, regulations or whatever, or how she got permission from them to do that as a volunteer or something. And maybe I'll get some feedback for you on that. The goofy guys. So that, yeah, her name is Nongaba. So I'll ask her and then maybe get back to you on that in terms of, but I know that they were working, I don't know if they were working hand in hand with the city of Cape Town, but they were part of that project as well. Yeah, I'm also not very pro city of Cape Town. I've got my own reasons.
Well, thank you. That would be great if you could find that out. I mean, just talking about this food forest in Gugulethu, I mean, it's a wonderful idea. And Brad Lancaster, who was possibly going to do a Zoom today, he's in Arizona, in Tucson, which has a similar amount of rainfall, as it turns out. And they managed to grow indigenous fruit trees there. So, we might have to look at species. Obviously, I don't see you maybe, growing sort of apple trees maybe, but if we can find indigenous species of trees, I think it would be stunning. It would be so amazing. And a source of vitamin C for children and all that, and shade and coolness and evaporation and all that stuff. It would just be really amazing. And it's doable because we've seen that with Brad Lancaster's project. I don't know if you've all seen his video, Planting the Rain. It's a TED Talk. I'd actually be happy to play it for you if you still want to see it. but you can also play it wherever you are because you've got internet now. But I can send you the link because it's a very inspiring talk that talks about how he went about things.
Jill, I got a suggestion for Guguletu crew regarding the concern about actually cutting curbs and that. If you observe which way the water is flowing in the road, where you want to get the water from, nothing stopping you from putting a pipe in there facing the direction where the flow is coming from, and the momentum of the water will automatically lift it up and over the curb for you. And the same thing with any stormwater drains, where you've got stormwater drains running under you and that's got water in it. You can do the same thing. If you lift the pipe up and back down again, you'll be able to use the momentum of the water to get it flowing automatically without a pump.
Yeah, I like it. And I mean, I suppose there's nothing really to stop you just putting a few bricks or a sandbag or something, there are various ways of, without making anything too fixed and unchangeable, but just sort of, I mean, there are lots of bricks lying around.
Yeah,
but I like the idea of the
idea
pipe.
is brilliant. Sandbags are great as well for redirecting water.
And I think, if we try and put in more temporary structures, I think the city will get encouraged, and actually think about digging, once they see that, there are some temporary structures put in place for stuff like this. And then they will actually see the idea and actually do the community without even hassling. But if we encourage them with the more temporary structures we put in, the more pipes, the more bricks try laying, they will see the idea and eventually figure something out.
Exactly. You lead, politicians will follow. Don't worry. Don't worry about the politicians.
I like it.
Well, thank you very much, Jill. Some great lessons. For example, I've got a banana circle in my backyard. It's thriving and we've been harvesting, and even now we're having a bumper season with bananas using our bathroom water. All it's diverted to our banana circle. But we tried the same thing with the kitchen sink, and it has killed everything around there. So good lessons.
Yeah, it's a pleasure, Vuyani. And as I say, I mean, this was just a very quick sort of introduction to a whole lot of topics. Whatever topics you still want to talk about some more, we can see if we can go further into them. So I hope it sort of at least gave you an introduction. I know, Vuyani, you know a lot of this stuff already, but we couldn't really sort of go straight into all the detail without, giving an overview of what it's all about, the context and, calculating and all that stuff to just sort of get that grounding, and then I think go in future sessions into more detail.
Good.
Okay, any other comments or questions?
From us? Yeah.
Okay. Well, thanks everyone for coming. I've really enjoyed this. It's been the first time for me speaking like this. It's a bit of a challenge, but I've enjoyed it. Thank you. And see you all on the next Zoom, I suppose.
Thank you.
Yes, thank you very much. Everybody can unmute and good night and thank you.
Yeah, thank you very much, everyone. Have a good night.
Thank you.
Bye-bye.
Bye.